instance, you will not be able to run any of the alternate technologies.
Yes.
You will be able to run a MACH.
What are the main advantages of the MACH reactor compared to other technologies?
Having said that, because of the venturis that we have inside the MACH reactor that give us the cavitation effect, though in between those venturis, you also get suction, so you get vacuum created through Bernoulli effect. So as the slurry speeds up through the throat of the venturi, instantaneous pressure drops to below water vapor pressure, and you start to generate cavities, and you also start to generate suction. So it's like a big vacuum cleaner in between the venturis. It's just pulling in whatever's around. And so that's where we connect our gas points. So if you're injecting oxygen into the reactor, even though that oxygen can have some pressure behind it, we don't mind that. But even if that pressure is as low as 1 or 2 bars, it will still get sucked in, it will get pulled in, drawn into the reactor.
Amazing.
And there's no other technology out there that has that. Every other technology needs high gas pressure, 8 or 10 bar, which is not always available on plants, especially very remote plants where the oxygen's generated on site with PSA machines, etc. And they only have about 2 bar pressure. That's all you have. So in those instances, you will not be able to run any of the alternate technologies.
Yes.
You will be able to run a MACH because it's not a requirement for us to have that high pressure. So that's a standout. That's again a standout feature.
It's really effective.
It is very, very effective. And then reactor capacity. That's another area. When I started designing the MACH reactor and I did the very, very first designs, I tried to do it in a way that scale up of the reactor wouldn't be an issue.
Yeah.
So, we could get bigger flows if we wanted to. The design could accommodate it. And in the last couple of years, especially talking to the base metal people in the base metal industry, that some of those plants have really high flow rates, all the way up to 3,000 cube an hour. And the question I got asked a lot at the various conferences is, it's all well and good, but can you make a MACH reactor that can do 3,000 cube an hour through a single unit? And it was a sort of like a challenge to myself. Can we do it? I don't know. Let's try a design. Let's actually build one. And so we've managed to build, there's quite a few of them that are large capacity, the largest being 3,000, but there's quite a few around 2,000 cube an hour that are installed already in the industry. They've been running for 3 or 4 years very successfully. And again, we're the only one that does that. The largest alternative technology reactor you're going to get will be about 600 cube an hour.
That's amazing.
That's a big difference. 600 cube an hour and we do 3,000.
Yeah.
So what it means if somebody wants to install those alternate technologies on the plant, they'd have to put a whole battery of them in.
Yes.
It's not uncommon for me to see 10 or 20 of those alternative reactors installed on a plant purely because those reactors are of a very low capacity, a low throughput.
Yeah,
so
can't reach that standard.
They cannot reach, they simply can't build one that will do 3,000 cubes. So to make up for that, you've got to put lots of them in, which, as you can imagine, can't be a cheap exercise for the client.
Ways. And it probably has the wear and tear then and all the other things that come with
now,
that.
Instead of having 1 reactor you've got to maintain, you've got 20 of them. Imagine that.
No.
I don't know what you would say for babies, like 1 baby. Imagine having 20 of them to handle.
And one's so expensive.